we have framing as the first service of data link layer. I told you framing is carried out by MAC sublayer. It's carried out by MAC sublayer of data link layer. Fine with you guys? Okay, what is framing? Here, first of all, let's discuss in brief, in depth, what is frame actually. What is frame? Group of bits is called as frame. Okay, a group of bits is called as frame. And digital unit of data transmission is also a frame. Frame is also called as data at data link layer. Okay, now why I'm saying this, it seems very simple, but no. This definition is in terms when the data is coming from physical layer to data link layer. Okay, the bits come from the physical layer, it takes it forms a frame. It's like that. But this is when the data comes from the upper layers, network layer. Okay, in network layer we have source IP, we have destination IP, we have payload in which we have data. Again we form this whole thing as a data. Again we add source MAC, destination MAC, the CRC, all the three together. Okay, this complete thing is called as the data at the data link layer. I mean data from the upper layers. I mean to say in simple words, bro. See, when sender application creates the data, okay, then session layer does something, presentation layer does something, transport layer does something, network layers add source IP, destination IP. This is network layer packet. This is network layer packet through sender side. Now data link layer forms this frame using this packet inside source MAC, destination MAC. This complete thing is frame. Now when it goes to receiver, right, this frame is sent in the form of bits. Again at the data link layer at the center side, we will group those bits. Okay, that is also known as frame. Getting my point? It can have two definitions. One is like framing is a process of converting the data coming from the upper layers into a frame which consists of source MAC, destination MAC and CRC. In short words is to say, framing is a process of adding headers and trailers to the data from the upper layer. From the receiver perspective, framing can be also called as grouping together the group of bits, grouping the bits in a sequence. Okay, now why do we need to do this? What is the need to do this? Let me explain you with a very basic example. Very basic example. Suppose you have a sender here. Suppose we have a receiver here. Okay, now actually sender creates the data calling hi bro. Example, he has created this data. Suppose this is represented 0001 1000. Example, it's not exactly like this, but let's suppose this has been represented as this. Okay, now once this data goes to physical layer, this will get transmitted as 0001 1000. See, does physical layer have sense that okay, there is a gap between hi and bro? Are you getting my point? It will not have. It will say, भाई जो भी मुझे आया मैं चुपचाप भेज दूंगा. It's like whatever you send it to me, I will just send it as bits. It's not like okay, I'll keep some time space here. Let hi go first. Let world go next. Bro, does it make sense at that high speed? No, definitely no. That is the reason some genius people what they said. We will think about a mechanism saying that we will keep some identifier to let receiver know okay, the frame is starting now. Okay, now here hi is supposed to be in one frame, bro is supposed to be in second frame. Getting my point? The starting point of the frame. Now they were thinking to add something before hi and something after bro. Now these are called as SFD, start frame delimiter. That SFD is nothing but which is actually used as an identifier that marks the starting point of the frame. Agreed? Now, the thing is, okay, they came up with a mechanism called as fixed size framing. Before even they discovered this, they came with a mechanism called as fixed size framing. They told our frames will be of fixed size. Okay, suppose if I want to keep my single frame of 1500 bytes, I don't know if a single message comprises high, it must fit into that, and if the remaining space is wasted, we will just put a padding as far as like default values 0 0 0 0 0, some default range of values. Okay, getting a point. Here I mean to say is the length of the frame itself is the indicator that the frame, this is a one frame. Okay, suppose we have length of the frame as 50 bytes. Okay, now I filled a message called as high in that frame, and the remaining space which is left, I'll put padding on that, filling it with some garbage values. Okay, which receiver doesn't understand. He thinks, okay, I just need to ignore this. Getting my point? Now the disadvantage here was simply the frame size is getting wasted if there is a smaller message, right? We, in famous terms, we call it as internal fragmentation occurs. Of course, bro, if you have 50 bytes length and if you just choose 10 bytes out of that, the remaining 40 bytes are just useless. This is unnecessary wastage of bandwidth, unnecessary wastage of memory, unnecessary wastage of space. Useless. That's the reason some genius came up. He told, okay, we will not use fixed size framing. We will use variable size framing. Nothing but dynamically we will keep on updating the size of the frame. And the second type, which is actually called as variable size framing. Now in variable size framing, he told, okay, you are wasting this much amount of length, this much amount of space. What I'll do, I'll just put a length. Suppose I am sending hi bro, and the hi occupies 25 bytes and bro occupies 35 bytes. Example 35 bytes is very huge value. Okay, you can fill up many letters into that, but here he sends hi. Okay, it has actual data, but here he puts a one more field called as length field in the headers of the frame. Okay, he puts here as 25. Now the second frame, which is bro, and it puts the length field here as 35. Now when it goes to receiver, the receiver will take the frame. It will see, oh, okay, the length is 25. The length is 25 bits. So he will decode till 25, not bits, bytes. Sorry. He will try decode until 25 bytes, and then it will think, okay, 25 bytes has been done. I will put it at one side till I receive the next frame, and then I'll send all at once. Okay. By this, the receiver will get to know, okay, when the frame is starting, when the frame is ending. Here also 35 bits, it'll start from here, 35 bits from here, it will decode this message, it will send hi bro to the network layer, and then to transport, then to application, finally it will go to end the application. Okay, this is how it works. But now some other jealous guy of this person came and he said, what if this field gets lost? Correct? This will also happen. See, headers are very easy to lose. Okay, headers are the things which are easily lost during transmission sometimes. Okay, because they are the outermost part of the frame, right? Those jealous guy came and he told, no, we cannot use this. We have to use some different technique. So that guy came up with the latest technique. Okay, now that is called as character stuffing. You want to send hi bro to receiver. What character stuffing says, we will use one particular flag character. So the flag here is called as start frame delimiter. Start frame delimiter is nothing but which marks the starting point of the frame and the ending point of the frame, which here is a character. Suppose you are sending hi bro, and they are following a mechanism saying that I will mark the starting of the frame using a special character called as dollar. Okay? Understanding? Now the frame sequence which will be formed here is hi but dollar hi dollar. Now when it goes to receiver, the receiver will think dollar, oh starting point of the frame, decodes hi, then again dollar, oh ending point of the frame. The same way bro dollar dollar bro. Same. You might get it out here. What if I want to send hi dollar? Here the flag byte is flag character is nothing but dollar. Here in this mechanism we also maintain an escape character. Remember in coding programming languages, right? To escape some bit we use /n, I mean \n. Okay, same here we use \0. Not always, but it depends on what the developer is choosing. I mean what the transporter or sender or receiver is choosing. Both they agree on common protocol. Okay, we use this as escape byte. Okay, now if I want to send hi dollar, now this message will be hi escape character dollar, then comes dollar, then here comes dollar. Getting? After hi escape character and then dollar. Now later on computer started speaking with bits as bits. Okay, then the same technique as this was implemented called as, this is character stuffing, also called as byte stuffing, but the next one is bit stuffing. Same as character stuffing but for digital, I mean bit encoded systems, x64 bit, Windows XL2 bit, Windows XP, Windows 7.1. Okay, now hi bro, suppose it's represented as 0010 0001. Example. Now it says my SFT, also called as flag, also called as start frame delimiter, starting point of the frame, if I am choosing it to be 0101 and I am choosing escape character to be not all ones, 1110, something whatever they choose to. Okay, something whatever they choose to. Now this data will be sent as, okay, first hi will be sent, next bro will be sent. Okay, so 0010 comes here. Before that the start frame delimiter 0101, and then comes this bro 0001, and then comes this escape bit 1110. This will be sent to receiver.